Okay, so hang on, just hold on. Don't get too excited. I'm in the business of making it worse first. When you guys sign up, some of you guys are going to be math teachers. Best job ever, so I highly recommend it. You guys will learn about how you torture first before providing relief. It's important. Remember yesterday when we created the need for shells? Now, I think we're going to have to create a need for shells and cheese. By making you skip lunch one day. That would create a need for shells and cheese. Okay.
Well, we could reuse that Velveeta.
Okay, well, speaking of Velveeta, let's fill this space with Velveeta. There it is. There it is, filled with Velveeta. Now, yesterday, I know what it says up here. Do the volume formed by going about the y-axis, both vertical and horizontal slices. I'm going to go, I think we're just going to go with shells, just because I want to show you how cool this is. So take that region about the axis. We're going to do. Shells is when you make little cylinders.
So when we just did on example 8.
So what you do, you spin it around. You have to make a duplicate on the other side. So I'm gonna do this in blue because I like the look of this. We're gonna create this, right? And it's gonna have a nice bowed inside. Same here. It's gonna come down to a little vortex down at the bottom there. It's like that animal in Star Wars where they fall in. It has those teeth. People fall down inside. You know what I mean? It's got what is that? The pit. Yeah, the pit animal. That one really freaked me out when I was little. That was just not a pleasant thought, just falling into a pit and getting devoured. It says you get digested for like years. I don't know. Okay, so what I'm doing is creating cylinder slices. So just imagine I could put together concentric cylinders all the way to the outer edge, and I could create this volume. So what I need is just one volume, one cylinder's volume, which I'll unravel over here. So take that cylinder out. I could make a bunch of those cylinders together. It's like taking that paper yesterday and I rolled it up. I can make a lot of different shapes. So this is dx. This is dx. It's the same sheet. If I highlight a little pink, let's put a little pink frosting on this edge right here. That's this right here. Remember, we're putting this on Velveeta now. So there's that region. And then the height. So here comes the fun. The height is the upper function minus the lower function. It's radical x minus x squared. That's the height of that piece. It's just how far apart the top and bottom are. The radius is the part that really is the hard thing to find for me. I think it is anyway. The radius is the distance from axis of rotation to that outer edge. I'm going to go back to black here. See that right there? That's my radius. That radius for us is going to be x because its axis of rotation is 0. It would be x minus 0, distance from the axis of rotation. So our radius, our r of x, is x minus 0. So the distance out here is to whatever x value I'm at minus the axis of rotation. A radius is always distance, and for ours it's almost always going to be x minus the axis of rotation for a lot of our work. We're going to go to some x value within the domain of the function, or the domain of the rotated region, minus the axis of rotation. So for most of our work, just think of it as it's going to be x minus axis of rotation. And you should be good to go for most of what we do. Axis of rot. So 2 pi times our radius gives you the distance around that cylinder, 2 pi r. And that's it. We got the pieces to the volume of our one piece. all we have to do is integrate that one volume. 2 pi times our radius times our height dx. And the interval is from 0 to where these intersect, which is at 1. That's it. We'll spin that around, make a cool little tulip with a Hershey Kiss in the middle. A hollow, so that could be a Hershey Kiss mold. Remember we were talking about, so let's talk about something more pleasant. If you filled that up with chocolate, which I think I could do. Do I have brown? Yep, I got it. Hang on. Hold on. So custom, where's the brownie? There it is, I got it. Fill it up with chocolate. Pull it out and you dump it out. And it would be a Hershey Kiss. But that's empty. It's a mold. That's a mold.
I'm just kidding.
Hershey Kiss mold. But you integrate, so this becomes our format for integration in general for volumes. If you can find the volume of one piece of the thing that you're making a whole bunch of, so this is one piece. We're doing cylinders, so this is one cylinder. We got one piece of paper, its volume. If you're using x instead of an actual value, like a variable, then it will create the exact volume. The other thing you want to keep in mind is that when we do the volume of a particular shape, let me get my color spectrum up. This will be good. The volume of this face, or the volume of this piece, remember, is area of the face times the depth. That's how we do any volume thing. It's always this area of the face, or the base, area of face, which is a rectangle, right, for us? Length times width times the depth, which is dx. That's the other way we do volume too. It's the area of a face of the structure that you're iterating, doing over and over again, times its depth. That comes up, I think, in the next slide, so I just wanted to bring that up real fast right here. So any volume that we created, remember back in the beginning, we were just shading the area of this face, which is a semicircle, times its height gives you the volume. The area of this face, which is a circle, times its height gives you the volume. The area of this face times its height gives you the volume. So that's the format we're following. It just happens to be that each shape that we're using to create this, that how we get those dimensions of those said shapes is a little complicated sometimes. Crazy, huh? Okay. So I'll let you read this. Now, just as a little aside, the next thing we do, this little piece of aside will help. I'm so glad I pulled this custom coloring out. This is really pretty. I'm getting a lot of color choices here. I want you to look at my squares. We're going to start doing volume with these little square pieces, little tiles, dx thick, s by s wide. So just so you know, area of a square is s squared. What we're going to do is take it times dx to make a volume. So just in case you forgot what an area of a square was. We have 10% of battery left. Lucky for you guys. And then triangles. Got this dx. But here's height and here's base. Half a base times height. That was an easy one. I might have a plug, now that I think about it. Okay. Oh, what about this one? This one's goofy. What's this semicircle thing all about? Did you know about this one? Let's do a semicircle real fast. Okay. Here's my semicircle. Isn't that nice? So dx, if you take a diameter, Like that? Well, the area of the face, remember it's all about getting the area of the face right there, times the depth. Area of the face. Oh, oops. Put the D back. What we use, though, is the, that was a thick thumb. We do D over 2 for the radius. Oh. Hello. No problem. Kind of sounds like one of my kids' toy phones. Okay. I like those kind. That's our radius. And y'all know the area of is, for the face, would be a half a circle, pi r squared. But we're not using r. We're using d over 2. So, and then times the depth. But the area, if we do it in terms of this, 1/2 pi times d over 2 squared, you see how we get 1/2 pi over 4 d squared, and then that makes pi over 8 d squared. That's where this formula comes from, in case you're wondering. Now, some people like using those. They're great. Others don't. So, I tell you, this relates to what we're going to do shortly. This is where the other class had some fun. I had some fun. Anyway. Rectangles, no big deal. We got this. No need to write dx, but length times width. And finally, equilateral triangles. Who makes this stuff up? There's an equilateral triangle, dx wide. The area of this, remember how this goes? Now they're using s as the length of a side, s, and so on, s and s. The height, do you remember how to get the height? Wait till you see this color I get to write in. It's a very, very nice pink. What do you know about the angles over here? 45 plus 45 plus 45?
No.
180 it does not make.
60.
60, 60, 60. 60, 60, 60. So this has got to be 30 because I split it. And you guys remember your 30, 60, 90. Always good to bring that up. So if this is, let's do 2. You guys probably like it this way. Remember that, 30, 60, 90? 2, 1, radical 3. So if this is of length s over 2, then this would be radical 3 s over 2.
Wow, that is.
Remember that? So if I want to do area with all that information, area would be 1/2 base times height and if you put the s's together, s squared. If you do the 2 times 2, you get 4, and there's your radical 3. Isn't that crazy? So this is a shortcut formula. I can't remember those. So that's why I built each one of these for you, because when you want to get the area, I can't remember. I just have to remember how to build an equilateral triangle. It has 30, 60, 90 triangle in it if you split it in half. And yeah, I don't do formulas well. So I have to do